All right, today I want to talk to you about lithium-ion batteries. I get many calls a day on lithium-ion batteries. Here is a typical one. Here is one that we used to sell, and we no longer have stock of. We don't do lithium ions anymore for the reasons I'm going to explain to you. It's just too much headache for people misunderstanding things. So I'm making this video for you to understand that. This is a 24-volt unit. Okay, so typically a lithium ion cell is about 3.2 volts per cell. If we had to equate this to cups of water, let's say each cell in your battery is a glass of water, all right, at different levels. Okay, one might be there. In the factory, hopefully they've balanced them all. Okay, and then you have a little BMS at the top over here. The BMS basically is like a little giant straw. It'll suck some water out of that cup over there. It'll suck some up over there. It'll push some in there, suck some up because that one's higher. Put some in there, trying to level these all out. Okay. So what can happen now too, because a BMS is designed to protect and stop this glass from overflowing. So if this cell over here overflowed, okay, the BMS also has a mechanism, a shutdown mechanism. Okay, it shuts down on a few things. It shuts down on low voltage. It shuts down on high voltage. Oops, I'm spelling problems. It shuts down on temperature, high and low. It also shuts down on overcurrent. Oh my goodness. Shuts down on overcurrent as well. Okay, so these are all the things that can cause a BMS to trip. When I say trip, it actually does a break in the circuit. I'm going to pause the video quickly and draw some more details on there. Okay, so a BMS does, like I said, a few things. The one is the cell balancing. So the cell balancing, it has to have balanced the wires, and you've seen obviously BMSs with individual wires going to each cell. Okay, I'm going to open up a BMS for you shortly over here. Then it also has a little electronic circuit that actually is a switch, okay? And that switch over there can trip on low voltage, high voltage, temperature high and low, and overcurrent. So a lithium-ion battery is essentially like a bomb that needs a little control circuit to keep everything nice and happy, okay? So I'm going to give you a demonstration quickly of showing you what happens, why you cannot balance lithium-ion batteries when you've got like 12-volt batteries in series trying to make up a 24-volt system. Okay, so one BMS inside this unit. This is a 24-volt battery, so it's a 16 cell. So there's 16 cells over here, and then a BMS to control all of these items over here. Okay, all built inside you. You cannot see it. Okay, I'm going to show you quickly a BMS, what it looks like from the inside. All right, so here's a typical BMS. This one is a 16S BMS. It's got the voltmeter on the outside. Now, the voltmeter is usually connected. Where's my whiteboard marker? There we go. The BMS, the voltmeter inside the BMS is usually going to be lying to you, okay? Because it's connected before the switch. So if the switch trips on the BMS, the voltage over here is still going to show you full volts, okay? But the BMS is open circuit to your inverter. Here's your inverter over here. Okay? So people call me all the time saying, well, my battery is showing me 12 volts or 13 volts or whatever the case is over here. And everything looks fine, but the inverter is showing a fault 4, which is low battery, or it's not coming on. So that's why I say to them, well, connect a voltmeter across your inverter terminals there, all right, and turn the switch on so that the inverter is putting a load on, you can see. And then straight away, because inside this little BMS, there's another little trick they're doing here. It hasn't just a normal switch. It's got a little resistor in there. Okay, so that little resistor, even though that big switch trips, that little resistor is still going to be putting a voltage through there, and if you've got no load on your inverter, if your inverter is disconnected and you're measuring your voltage there, you're still going to get full battery voltage because you're measuring through that little resistor. Remember, you only get a volt drop if there's current going through a resistor. So your voltmeter doesn't draw any current, so you're just measuring the voltage, basically exactly the same voltage that's on your battery. Okay, so it's going to confuse you. That's why I ask every time people say, oh, my battery's showing 13 volts, but the inverter won't come on. I go, yes, put a voltmeter across your inverter terminals, turn the inverter in the on position, and read the voltage there. And they go, oh, well, it's only showing 4 volts. I said, yes, because you are measuring through that resistor over there, and that breaker inside the BMS has tripped for any one of those reasons. Usually, it's overcurrent. Okay, and I'll come to that right now. So I'm going to show you the behavior of a BMS and how tricky this little guy is. Okay, once you understand these concepts, things come into play. Like I said, because this is a 24 volt unit with 16 cells, I'm going to connect a bench power supply up to it. I'm going to connect this bench power supply up at 13 volts. All right, so basically what should happen is, as I connect it up over there, the voltage from the battery should feed back to this little power supply meter inside there and push it up to 26 volts. And as I pull it off, obviously you can see that's what the voltage meter is set at. I can set this thing at 4 volts, for example, and connect it up there, and you'll see it jump to 26 volts. Okay, but now let me show you some strange behaviors of a BMS. Okay, this battery is fully charged. I've charged this thing up with this power supply. I want to show you quickly. So I'm going to increase the voltage on this power supply. Okay, it's a 5 amp power supply, and I'm going to charge this already fully charged battery. Okay, so hopefully in a few seconds, basically what it's doing is all these cells are fully topped off over here. They're all pretty much equal. The BMS has done its job overnight, and they're all basically at the brim of being over full. Okay, let me just draw these lines in here. So it's pretty much all full. Okay, so the BMS, obviously we all seen YouTube videos what happens if you keep charging a lithium ion battery without a BMS. Okay, maybe I'll even add a link over here. The Tesla batteries explode. Some lithium iron phosphate batteries, that even though they say they don't explode, they do. Nissan Leaf batteries bulge, they get hot. So it's dangerous. Okay, so the BMS can only do one of two things. So basically, let me show you this power supply. I'm feeding in like 52 volts. Okay, maybe I'm going to drop it just a little bit, because if the battery goes open circuit, I don't want to. So 32 volts. Okay, so I'm putting 32 volts on a battery that is 26 volts. You can see that the battery is winning, right? It's pulling my power supply down to 27 volts, which is basically what the voltage is on the cell, and that's 5 amps going into this charging circuit. So getting back to this over here, so all these cells are right at the top, right at the top. The BMS has got no choice eventually but to go open circuit for high voltage soon. Okay, and when that thing goes open circuit, high voltage open circuit, you'll see what happens shortly. But while I'm waiting for that to happen, I've let this balance a little bit overnight, so there's still a few more amps that can go into it. While I'm waiting for that to happen, I'm going to show you what's inside this BMS. Okay, so there's the voltmeter that you normally see inside your BMS that I showed you. That's sitting over there, over the cells, in front of the BMS resistor and everything. Okay, if I open this up, you see this is a 16S BMS. Okay, you'll notice a few things. First of all, the BMS is only connected to the negative wires. Let me pull this wire out the way over here, just to show you. Let's get this. Oh my goodness. Okay, so this is for the battery negative terminal. This is now inside this. That would be inside this box, or if you're building your own BMS. Okay, that would go to the battery negative terminal. It'll go through this solid state switch, and there's the negative wire that goes to your battery, and you'll notice that the positive wire doesn't even go through the BMS at all. It goes through this little trip switch, and here's the positive wire over there. So the BMS gets all its power from this little connector, and you've seen these connectors over here with a multitude of wires going to each of the cells of the batteries over there. Goes to each of those cells of the batteries and monitors the voltage on each of those cells. Okay, so you can see, so the BMS over here is rated at a certain amperage. This one is rated at 60 amps. Okay, so in other words, if my inverter load is more than 60 amps, this thing's going to trip. It's going to go open circuit. Okay, so 60 amps is, let's figure out. So people buying a BMS thinking, oh, well, you know, I've got a huge battery. I've got a 100 amp or a 60 amp BMS. I'm going to just install it. It should be good enough. I'm going to show you why it might not be such a good idea. Okay. Okay, we should have learned that watts is equals to volts times amps. Okay, so let's say our BMS is limiting us to 60 amps. Okay, and then let's say this is a 12-volt battery for argument's sake, 12-volt battery. Okay, 12 times 60, I think it's 72. 720 watts. So even though we might have a 1000 watt inverter at 12 volts, the moment this inverter draws more than 720 watts, the BMS is going to trip. All right, you've got this electronic trip switch. So people pull their hair out all the time, going, I've got this massive battery that's 400 amp hours or whatever the case may be, but the BMS is only rated to 60 amps. So that is the biggest amount of current, surge current, that this BMS can handle before it trips. Okay. Oh, look what just happened right now. My power supply, it is acting as if the battery has gone open circuit. You notice that? Look there. So now my power supply is set to 31 volts. If you can remember, the amps are dropped to 0. And so this BMS now has what you call tripped. Okay, that switch is open circuit. So if I had to put a voltmeter on there, Dirk, have you got a voltmeter? I'm going to show you this power supply is drawing a little bit of power. Okay, so it's putting a bit of load on this battery. Let's put a voltmeter directly, DC volts. Perfect example. Look there. The battery is showing 26.47 volts, but it's lying to you because it's showing you through that little resistor over there. Okay. Now if I put any load on there, the voltage is going up to 32 volts. Okay, because my meter, it's not pulling my power supply down. But the moment I pull my power supply leg off, it goes 26 volts. Okay, but 26 volts at 0 amps, because that little resistor over there will be limiting any power to go through this battery. Okay, so I'm going to show you. I'm going to try and find a little load here that I can put on across here to show you that 26 volts is 26 volts that can do no work. It's like taking a comb, rubbing your hair, getting thousands of volts, and expecting that to power the world. It just simply doesn't work. Volts is not power. So now I'm going to use a good old-fashioned pencil. We all know a pencil is made of graphite. Graphite is conductive, it's carbon. So this pencil at the moment is 8.5 ohms, okay? So 8.5 ohms at 25 volts. So remember your volts IR triangle, okay? So if we know that our volts is 26 volts and our ohms are 8.88, our amps, so 26 divided by 8.6, about 3 or 4-ish, all right? About 3 to 4 amps. 4 amps, okay? So if I put my pencil across there directly, okay, which is very difficult to do now using one hand, you'll see that this battery doesn't put any power at all through this pencil because this resistor is limiting it, okay? Look there. Nothing at all, okay? So this battery is lying to us. So the only way to reset the BMS now, that's the next question people ask, is how do I reset this BMS? How do I reset that little switch over there, inside there? Okay, there's a number of ways. First of all, you can just let the battery rest for a little while. And after let it rest for a little while, you'll notice that when I put my clamp on there, it's still not allowing any power to go in. So I have to just let it rest, okay? And this is another point I want to bring out. So while your inverter is trying to charge this battery to 26 or 27 volts and you've got it set to 28 volts, the moment it reaches higher than the over voltage setting inside the BMS, the battery just simply goes open circuit, which usually throws a fault code on the inverter, like fault code 8, high voltage, and then it won't start charging the battery again until the battery is like fully discharged in the next day. And many people ask me, well, you know, the inverter is faulty, you know, it won't charge my battery. I'm going, no, what's happening is your battery is tripping, and the inverter has gone into fault because it pushed the voltage up internally. I mean, the inverter is trying to charge that battery up. The inverter battery voltage kind of spikes because it's charging an open circuit battery, throws a fault, and then the inverter won't reset itself because there's a problem. Okay. So I got a 24 volt grow watt inverter over here that I'm going to connect to this battery, and I'm going to show you now. We know this battery is fully charged, so I'm going to show you. I'm going to try and charge this battery even more with the grow watt, and I'll show you how it behaves. And this is the same for MPP solar, grow watt. All inverter and charge controllers you're going to confuse their brains a little bit. Okay, so another way to trip this BMS is, we've already mentioned high voltage, right? Now let's do overcurrent. Overcurrent, high voltage is easy to do. Overcurrent is even easier to do. Okay, we've all seen this spark when you connect the positive to the negative terminal straight away. Okay, what's going to happen is you have got in this inverter. You got some capacitors inside there. I'm just going to say a tank, right? You got a tank that is empty. Okay, and then in the battery you got a tank that is full. Okay. And now with these big fat wires we're using over here, we're connecting this tank to that tank, okay, with these big fat wires. And so what's going to happen is this battery is going to try as hard as it can to fill up this tank over here, okay? And that's that big spark that you see. It's all those amps. And all those amps going over there, it can be hundreds of amps, 100 plus amps flowing through there to try and fill that up. So we need to slow that down a little bit, because the moment we touch this wire to the inverter, we can trip the BMS, the switch again, all right? And then we go back to the same situation as we had with the over voltage situation, okay? So we've all spoken about a charging resistor also, but a little old pencil, like we've just measured, is 8 ohms. It's cheap and nasty. Any pencil will do. We sharpen it on both ends. Dirk, just touch that wire on the end there, see? You'll see there's a little, and that's it, all that 8 ohms, okay? Took a few seconds, and now we can touch it straight on there. We can take this terminal off. Now, okay. Okay, now we've got our battery connected to our inverter. So we've charged up those capacitors inside there with the 8 ohm resistor. Now we can turn the unit on. You can see now the battery, the BMS obviously reset itself after a little bit of time. Okay. So this is an old beat up inverter. We've had some, well, you know, we get some inverters come back in strange ways. So now I'm going to show you what happens is I'm going to try and charge this battery again from this inverter. Because we're changing things all the time, we've pulled in a 240 volt plug from our utility with a typical 240 volt plug on there, going through these current transformers to show you guys how much power is being drawn into our red and black phase over there. Because there's only a single phase inverter, we're only using the black phase coming through there. So we can turn the black phase on. You'll notice that straight away the little power line symbol comes on over there, which shows that the inverter is that the utility or grid power is on. And you can see straight away it goes into bypass mode because it knows the battery is fully charged. But now I'm going to force it. It's going to try and charge that battery a little bit more. You see there in utility mode, setting 01 set to UTL, which means that that's the default. And it's going to try and charge this battery even more. Okay, so utility. So this battery can only reach, in this case, 27 or volts. If you wanted to charge at 29 volts, it will go to 29 volts instantaneously, and when you let it go again, it's going to come back down to 27 volts. And we see that so many times with people saying, well, this inverter doesn't charge my battery fully. There it's showing you 28 volts. Okay, I can put this power supply on as well. But And the moment I let this battery rest, you can see it's 27 volts. Okay, so people say, well, why is my 28 volt battery staying at, this thing won't charge it fully? It's because the BMS is controlling the charge rate. Okay, so, and you can see the battery voltage is now down to 26 volts, which is where this battery is happy at being. Okay, so this charger won't charge this battery anymore. I can't explain this over and over because I have so many phone calls with people misunderstanding this. Okay, now I'm going to try something dangerous. I want to get this BMS to trip on overload. Okay, and all I'm going to do is connect the battery terminal without using my pre-charge resistor, and I'll show you. My inverter is on. Actually, switch that utility power off there. Okay, the inverter turns off straight away. Okay, so now I do that a few times. Okay, this battery is pretty bulky, but many of you guys just touch it the first time, and you can see all those big sparks over there trying to charge that tank up almost immediately. So if I had a smaller BMS, this would have tripped straight away. The only way to get this thing to untrip is to put power in the opposite direction. So I normally use a power supply. I'd have to connect my power supply on there and supply 26 or 30 volts into the battery, then it resets the BMS. Or I take a solar panel, a single solar panel. Obviously, I don't want to put 100 volts on my 24 volt battery, but I can put a single solar panel of 30 volts or so over the terminals to get the BMS to wake up. Let me see if I can get this thing. Okay. Because I get guys doing this 100 times, and then the 101st time it trips the BMS. Okay. And it also depends how thick the cables are. But you can see how I've pitted my brand new battery terminal already just by bad practices. Okay, if I use good practices, I would use my good old-fashioned pencil. And my inverter is also on at the moment, but you'll notice it gives me error fault code 4, which you've seen before in your BMSs, because this is an 8 ohm resistor. So the moment the battery is 26 volts, so this pencil is soaking up another 4 volts, and we're getting a low voltage warning. Plus the inverter is warning us you might get a 56 fault as well. 56 fault is showing that the battery is not able to provide the load required to the inverter. Okay, so bad connections can do many things. Okay, let's see if I can get it to come on again. Okay, these are common things I deal with every day. Okay. And then we'll get fault code 4 coming up soon, the moment the inverter tries to turn on. Okay, you saw that battery voltage drop down to 16 volts, fault 56. That's because you've got this pesky resistor in the way, okay, inside your BMS. Now let's get the BMS out the way, and you'll see the inverter is showing 25.9 volts, and it will come on shortly, outputting 120 volts. There we go. All right. Since my last clip, we connected some solar panels. The wires run outside. They've got 2 panels in series. It comes in 72 volts or so. You can see the LEDs on, showing that there's power there on that the first circuit. This is a 4-2 combiner box. So the first circuit is positive, and that first fuse on the other side is negative of the first panel. Okay, so we've got a battery that's fully charged, like I explained earlier, and so now I'm going to try and charge this battery. I'm going to show you what happens when you guys overcharge a battery. Okay, what it does to the inverter. Okay, so I'm going to turn the solar power on. Okay, to the inverter. You can see it'll wake up. Okay, now it's going to try and charge the battery. Okay, which is a 26.4 volts, and when you'll see that voltage will spike up because the BMS is just ready to, so fully charged, the BMS is just ready to trip on over voltage. Okay, you can see there. It's charging. Now watch the battery voltage very carefully. I get calls on this all the time. Say my inverter stopped charging. And this is why. Watch that battery voltage. Okay. Look there, you see 31 volts, it suddenly jumped to. Usually it might give you a fault 08, but now that solar panel will not charge that battery because it detected that there's something wrong. That battery went open circuit to 31 volts, you saw that. So now, if I turn this inverter on, if I disconnect the solar voltage, this little solar panel icon will disappear in about 15 seconds. If I turn it back on, this battery will not charge again until I disconnect the positive off this battery and reset this inverter completely. Okay, it's not a problem with the inverter, it's a problem with your battery. Your voltage that you're charging it at is too high. Okay, I know this one can only take 27 volts and the setting on here is probably 28 volts, and so you saw that with your own eyes. Okay, so now if I turn the solar back on, and you can see I've got the set for sealed lead acid battery. I haven't changed it to lithium iron phosphate, so lead acid battery wants to charge it at 28 volts. Okay, it's just a... So the inverter is kind of hung up right now. If I turn the solar back on, okay, this unit will not charge again. Okay, so what I have to do now is turn it off. It's off already actually at the bottom there. Turn it off. Disconnect my battery terminal, let the inverter power off. Okay, then I use my pre-charge resistor again. You see that? Okay, all good. Put that battery terminal back on there. Now the inverter is reset. Okay, now what I'm going to do quickly is set my and that you see that one button is missing on this thing. It's probably a bad choice to use. My float voltage and bulk voltage, look at that, bulk voltage is set to 27 volts. Okay, I've got to drop that down. Otherwise it's going to overcharge the battery again. I'll show you that one more time. Now the solar's charging again. You'll soon see, you see that went to 28 volts, 29. The BMS is just holding on a bit longer than the last time. But once that inverter goes into this mode, you've kind of cooked its brain a little bit. Okay, see there? Typical sign of a BMS messing you around. On, off, on, off, on, off, on, off all the time.